Okay, we're going to start the third topic in calculus, basic integrals. And so we've talked about limits, okay? Limits, which is the definition that gets us ready for derivatives, and then derivatives and integrals. And what are each of these used for? Well, the derivatives basically is going to help you find slope or the rate of change, okay? So this is the best wording right here, rate of change. So if we have an object, say, following this function right here, and I want to know what is the rate or how fast is this going or at this particular point. So I can find the slope at that point, or that represents the rate of change at that point. The integral, on the other hand, is used to find the area under a curve. So in geometry, you could find the area of a circle, you can find the area of a triangle, you can find the area of a rectangle or a square, but could you find the area of this weird shaped thing right here? So it kind of looks like part of a bridge or something. That's what calculus allows us to do, is to find the area from like 0 to 2 of the function y equals x squared plus 3, or whatever this function is. All right? So recall when we did derivatives, the derivative of this is I would move this term in front and I'd get 3. The exponent would go down 1, x squared. But also remember that if this was the function, I would still get 3x squared. You get the same thing. So we don't know if in integrals we're actually going to start with this and go backwards. So it's the reverse of derivatives. We're going to start with something like this and go backwards. So to do that, if I started with 3x squared, what you're going to do is you're going to increase the exponent by 1. Remember, we decreased it by 1 when we took the derivative. And it's funny, decrease and derivative both begin with a D, and increase and integral both begin with an I, so a way to help you remember. But then we also have to divide by whatever that number is, divide by that number. So let me show you. I'm going to take this 3x squared and I'm going to add 1 to it. Okay, so here I'm going to get x to the third, and now my new number is 3. So let me put the original 3, and then I'm going to divide by 3, and you see how that just gives me x to the third. Oh, that's what I started with over here, and I got this way. But I have to add a constant, because we don't know if this constant is going to be 0, like it is here, or if it's going to be an actual number like 2. So everything you add a constant. So let's do another example. How about if I tell you to find the integral, and this is the integral symbol. Integral symbol. If I ask you to find the integral of 8x to the third, okay, what you would do is you're going to add 1 to that exponent. I get 4. The constant or the number stays the same, and you're going to divide by 4. So 8 divided by 4 is 2, so I get 2x to the fourth plus my constant, and that's going to be my final answer. And we just put plus c for now. Okay? And then one thing you might remember is, what is the derivative? What is dy dx when y equals ln x? Remember, the derivative of ln x is 1 over x. So we have to see if we have 1 over x and we take the integral of that, that's going to give us ln x. Right? Let me give you another example. What if we take the integral of x squared plus 6x minus 8, and then dx. That tells us we're taking the integral with respect to x. All right, so we're going to handle each of these terms separately. So for this first one, or for all of them, we're going to basically add 1 to all the exponents. Okay, here we have to add the x because there is no, it's x to the 0, right? So we're going to get x to the third, and then we have to increase by the exponent by 1 and divide by that number, plus 6x squared, 1 plus 1 is 2, divided by 2, minus 8x. I have to add that exponent, and then I have to add my constant. And so when I go to simplify, I'm going to get 1/3 x to the third plus 3x squared minus 8x plus c. And this is my final answer for that problem. Okay. I'm doing 10 examples here. So here's my third example right here, where I'm calling this number 3 on mine. Let's find the top of the page. Here's a third example. What if I take the integral of x to the third minus 1 over x to the third with respect to x? Okay, so I'm going to simplify that to the integral x to the third minus, I'm going to bring this x from the bottom to the top, x to the negative third. And it's much easier to see it that way. And when we go and we're going to add 1 to each of the exponents, I'm going to get x to the fourth over 4 plus, what's negative 3 plus 1? Negative 3 plus 1 is negative 2, so x to the negative 2 over 2. And then that simplifies to 1/4 x to the fourth plus 1/2 and x squared on the bottom. Okay, plus c. You always have to add that plus c because we don't know if we take the derivative of this term right here, we're going to get this problem up here. See, 4 times 1/4 cancels each other out. You go down 1, x to the third. And that's another way you can check to see if you had it right. You can take the derivative and go back and did you get the original answer. But this constant, the derivative of a constant is just 0. So there could be like a plus 0 there. All right. Here's a fourth example. What if we have the integral of 1/5 minus 2x to the third plus 2x. All of this is with respect to x. Okay, all of this is with respect to x. And we have to take the derivative of every side. Well, this is a constant, so what I have to do is I have to add an x. If it's just a plain number, you add the x. Okay? And remember this one, I can think of it as negative 2x to the negative third. So if I add 1, I'm going to get a negative 2. So we're going to get minus 2x to the negative 2 divided by negative 2 plus, I'm going to add 1 here. So I have the 2x, 1 plus 1 is 2 divided by 2 plus c. Well, I can now simplify this. So I'm going to get 1/5 x, a negative and a negative make a positive, so plus x to the negative 2, which is 1 over x squared, plus, these 2 cancels, I get x to the third, plus c. Oops, I'm sorry, this should be a 2, x to the 2, because 1 plus 1 is 2. I don't know why I wrote a 3. Okay? All right, you were all thinking that, find Miss St. John's mistake. All right, let's keep going. Here's a fifth example. What if I have something like 1 over the 4th root of z to the 5th? Well, how do I write that? Well, my little, remember, this is the root. It's on the bottom, and you have the root on the outside. So when you go to simplify this actually becomes 1 over z to the 5/4, or the integral of z to the negative 5/4. Oops, put that on the camera. Or z to the negative 5/4. So if I want to just simplify it, and I'll just write it over here, z to the negative 5/4. Now I have to add 1 to both sides because I'm increasing the exponent. So my 1 is going to look like a 4 over 4. And we get z to the negative 1/4 divided by negative 1/4. Well, that is the same as, if I flip this, negative 4 z to the negative 1/4 plus c. And then I can change that to negative 4 over z to the 1/4 plus c. All of that. So this answer up here is also acceptable. Usually on a multiple choice, the answer will be simplified, so to all positive exponents. So you'll probably see something like that. All right. Here, let's do another example on this page. What if I have x to the -1? Okay, x to the -1. Well, what's going to happen if I add 1 to it? If I add 1 to here, if I add 1, I'm going to get 0. But can I have x to the 0 over 0? Right? I cannot divide by 0. Okay. Oops. Cannot divide by 0. So if you get something, I'm supposed to say cannot divide by 0. If you get something where you have a 0, that should be a huge clue to you that you could rewrite it as like this, 1 over x, and then this should, I forgot my dx's on some of these problems, that's okay. If I have 1 over x, then you should be able to just go ahead and quickly realize that, oh, that's 1 over x, then that's going to be ln x plus c is going to be the answer for that one. Okay. Let's do another problem. Okay, let's say I have the integral of 2x to the -1 with respect to x. Okay, well again, if I add 1 to that, you're going to get 0. So you might want to see it as 1 over 2x, right? So now this is, it's going to be ln x. It's just like that last problem. But we have to, this is really, we're going to say 1 over the box divided by the derivative of the box. Okay? 1 over the box divided by, or times, 1 over the derivative of the box. Okay? D of u. So this is going to be not 1 over the box, ln of the box. ln of the box. So I'm going to get ln of 2x divided by 2. And I can rewrite that as, this is just 1 over 2 ln of 2x. That's going to be my answer. Let me do another one. Okay, let me do another one like that. What if I have the integral of 1/3 x? Okay, well, this is already on the bottom. You can consider this as a constant. I can write that as 1/3 times 1 over x. So constants, you can actually pull out on the other side because they're not going to change. So I'm going to get 1/3 times the integral of 1 over x. Oh, I forgot my plus c up here too. I'm really good at forgetting the plus c. So if I simplify this, I'm going to get 1 over 3rd ln x plus c. Okay, so this is, if you have something with a negative, it's going to be ln of the box divided by the derivative of the box. Here's a better example of that right here. And then with a constant, you can pull a constant out. All right, let's try an example like this. How about if I do the integral of 3x? Okay, well again, this is thinking about this having a constant. I can pull the constant on the outside and I just get 3x. So my answer is going to be 3 x. What is my exponent? 1. 1 plus 1 is 2 divided by 2 plus c. So that's my answer right there. Okay, and my last example, I'm going to try to do this quickly. My last example is, say I have the integral of x plus 2 squared. Well, right now, we'll have to expand that out, and we know that x plus 2 times, I'm going to make that a 3 just so there's not enough 2's. So there's not so many 2's. So we're going to get the integral of x squared plus 6x plus 9. You have to actually expand this out to take the integral of it. And so now we're going to add 1, divide by 3. Add 1 to the exponent, divide by 2. It's just a plain number. I'm going to add an x, and then I'm going to say plus c. So I'm going to get 1/3 x to the 3rd plus 3 x squared plus 9x